Okay, good morning, everyone. In today's lecture, we are going to study the last distribution, which is the normal distribution. Like I earlier explained, there are two types of random variables. One is the discrete random variable. Discrete random variable in which this random variable takes discrete values. So I can roughly say that belongs to the set of whole numbers. Uh, the probability distributions where your random variable is discrete are binomial and Poisson. Binomial and Poisson. In these distributions, so in these distributions, probability was assigned at a point. Okay, so you had some value of r, and the probability was assigned at a point x equal to r. Okay, so each value of x, say x1, small x1, x2, x3 to xn. So each of them will have some probability p1, p2, p3, so on up to pn. Okay, but there is another random variable which is continuous random variable. Continuous random variable. Under this continuous random variable, probability at some value of x. So probability of x is equal to say some point x1. This makes no sense. Makes no sense. Okay. So for continuous random variable, probability at a point makes no sense. That's what I want to say. But under continuous random variable, what we have is we have probability mass function, or which is also called as probable normal distribution curve in the normal distribution. So you have a function. A function is given to you. Okay, is probability density function. Okay, so what this function does, this is a curve, whatever it is. Okay, so for an example, I can give you say e to the power minus x. So what this function does is, so this is this is going to give you uh, some curve, okay? And for an example, I will draw a curve. So if this e to the power minus x, when I'm taking this, or let me just change this to 1 upon 1 plus x square, that will be much better. So this graph will look like this. Okay, when I draw this, so consider that I'm right for now. Okay, and in this case, when I want, say, if I want to find the probability for -1 less than or equal to 0 is less than or equal to 1. Okay, less than or equal to x is less than or equal to 1. Sorry. So as I said, probability at a point doesn't make any sense when I'm talking about continuous random variable. But in this case, you will have some function, a probability density function. So area under the probability density function, area under probability density function function is probability. Is probability. So what do I mean by this? So when I have this as my probability density function, PDF, okay, and I want to find the probability from -1 less than or equal to x is less than or equal to 1. This will be equal to -1 to +1, the probability density function 1 upon 1 plus x square dx. Okay, so I find out this integration, whatever is the answer, that will be probability for the interval -1 to +1. Am I clear? So are you clear with the concept? What happens when we have a continuous random variable? I need someone to reply on this. Is it
Yes.
clear? Yes, fine. So this is how continuous random variable works. So now just can you tell me if I have 0 less than or equal to x is less than or equal to 0, which will actually mean that probability at x equal to 0. So this will be integration from 0 to 0, 1 upon 1 plus x square dx. So if you find out, say, whatever is the answer, capital F of x for instant 0 to 0. So that will be capital F of 0 minus capital F of 0. The answer will turn out to be 0. Okay. So that is why probability at a point won't make any sense. Probability will always be equal to 0. So when I'm talking probability for a continuous random variable, I will have to take the integration of the probability density function, right? So now normal distribution here, normal distribution. So it is a continuous random variable. Okay, first of all, the variable which we use here is continuous random variable. So in this case, when I want to find out the probability, I will have to integrate. Okay. So which function I have to integrate? So probability density function or uh, the normal distribution curve, which is also called as normal distribution curve, is given by is given by y is equal to 1 upon sigma under root 2 pi e to the power minus x minus mu square upon 2 times sigma square. So this is your probability density function for normal distribution. So if I want to find the probability between any 2 points x1 and x2, so probability for x1 less than or equal to x is less than or equal to x2. This will be given by integration x1 to x2. Don't write this, just understand. So integration x1 to x2 1 upon sigma under root 2 pi e to the power minus x minus mu square upon 2 times sigma square, right? But I don't want to do this. Every time doing this integration is a tedious job. Okay. So solving this integration every time for every example is not a easy thing. So what we do is we simplify this equation. Now how do we simplify? Okay, so this integration, to simplify this integration, what we do is whenever I'm given any data, okay, so for that data, so this curve will lie somewhere around this, okay, somewhere like this. So for this data, I will have mean, right? Say x equal to mu. The mean will be somewhere here like this. Okay. So what I do is I shift this curve. Shifting the curve and changing the scale, changing scale by sigma. So what do we get? I will have a new variable z is equal to x minus mu divided by sigma. So I do this substitution. And by doing this substitution, what will happen? So mu is wherever the mu is, when I take z, so this curve will shift to the origin. Okay, it will shift to the origin and it will become symmetric about y-axis. So when we do this change, z is equal to x minus mu by sigma. So I have shifted this curve by mu. I have changed the scale by sigma. And what happens is after doing this, this new curve is symmetric about y-axis. Okay.
Sir,
Once it is, yes,
sir, in the place of x, we will substitute z, right?
no,
In the main equation.
like in the earlier example, whatever values of x I have, from that value, I will subtract mu
Okay.
and
Mu and
divide
then divide.
by sigma. So I will get a new variable, which is z.
Okay. Yes.
Okay.
Yes, sir.
So when we do this change of variable, this is the change of variable that we have been observing, right? From the first example of statistics, change of variable. So we change the variable in such a manner that the new curve that I get is symmetric about y-axis. Can someone tell me what will be the total area under this curve? Total area is equal to what is area in this case? Area is nothing but
Sir, integration of that curve from
huh.
the limit. Yeah.
So integration gives me integration between
Area
two
under.
points. So what should be the total area here?
Sir, sir, 1.
Integration of the equation y.
So what answer you should get? Chirag said it. What is the answer, Chirag?
1. 1.
One.
Because total
Because
probability.
so total probability is always one, right? And area under the curve represents the probability for a
Yes.
continuous random variable. So the total area has to be equal to one. Okay. So when I shift this curve, now what is happening? The curve is symmetric about y-axis. So this much area has to be
Half.
half.
50%.
So this much area is 0.5. The left hand side area is 0.5. Okay. So if you want to write some things down from here, you can write it down. You have 2 minutes. Then I'll make these remarks about the normal distribution. Look, these observations are important because all the examples will be based on this. So curve is symmetric about y-axis, total area is 1, left hand side is 0.5, right hand side is 0.5, these things. So I have posted a table on your group. Okay. So this table gives me the values for integration. Okay, so you don't need to find out the integrations every time. You can use the table, you can get the value of the integration, and that directly can be used in the example. Okay, once you change the variable, what I said, you have a original data, then you change the variable as z is equal to x minus mu by sigma. Whatever the new answer that you get, that for that values of z, this table will work, and this table will give you the answer for any integration. Okay, so before I go ahead, let's just make this remark number one. Probability for distribution normal distribution is the area under the curve, under the normal distribution curve. Normal distribution curve. Okay, changing changing the variable z is equal to x minus mu by sigma. Make the curve symmetric about y-axis. Third one, total Hello, am I audible?
Yes, sir. Now you are audible.
So the third point, total area under normal distribution curve is 1. Fourth one, so after the change of variable, area to the right of y-axis is half, and left of y-axis is half. Fifth one, area area under the curve under the curve after the change of variable, the change of variable is given by the statistical table. By the table. Empty table. Okay. And sixth and very important one, for normal distribution, mean is equal to mode is equal to median. So this last point is very important because uh, and this normal distribution is very important because this is the most symmetric distribution. By symmetric, I mean to say that a, under this under this distribution, all mean, median, and mode, all of them are same. Moreover, the curve that you always get is a bell-shaped curve. So it is mesocultic. It is moreover for skewness. If you see skewness is zero in that case. So all these things make this distribution very important. Fine. Now let's study some example. Just give me a minute so that I... Okay. Example. Find the area under the normal curve in the following cases. First one, z is equal to 0 and z is equal to 1.2. Second, Z is equal to minus 0.68 and Z equal to 0. Third one, Z is equal to minus 0.46 and Z is equal to 2.21. Fourth one, Z is equal to 0.81 and Z is equal to 1.94. Left of Z is equal to minus 0.6 and sixth one. Right of Z is equal to minus 1.28. Okay. So the we just have to find the area and your changed variable is already given to you. So area, I'll draw the diagram first of all. Change variable is this. The curve is symmetric about y-axis. So z is equal to 0 is this. This is your 0. So z is equal to 1.2. So area from 0 less than z is less than 1.2. So what you have to do is, so in the table, so this is the last and very important point, how to use this table. So the table represents the area from 0 to z. Okay. So in this case, I have 1.2. So you open your table. In the table, from the first column, you find out where it is 1.2. So 1.2 के आगे 0 है. So 1.2.00. So what is the entry? 0. Look at 1.2 and the first column. 0. You have the table on your group. Please go through it.
Sir, 0.3849.
0.3849.
3849.
3849. Okay. So the table which is given to you, it represents the area from 0 to the point z in this case, whichever point it is. Just like you look at a log table, in the same manner you have to look into this. What is the second one? This is your first. Second one, area from minus 0.68 less than z is less than 0. So I will draw the diagram for this. So where do you find minus 0.68? So minus 0.68 is somewhere here. Minus 0.68. This is the area I have to find out. So you can see that there is no negative value in your table. But what we know that the curve is symmetric about y-axis. So area from 0.68 less than z less than 0 will be equal to the area from 0
0 to
less
0.
up to 0.68. Now this value can be found out using table. So that is 0.6 and look at the 8. So that is 0.2518. So if you have any problem up to this, please let me know.
There is it 0.219
What?
for area of the second part, second question.
No, the answer is 0.2518. No?
Yes, sir. 0.251.
Third. The third one is from minus 0.46 to plus 2.21. In every normal example, I mean normal distribution, first of all you draw the diagram. The diagram will play a major role in this case. So we have to find the area from minus 0.46 less than z is less than 2.21. So this will be minus 0.46 and somewhere here will be 2.21. So this total area is to be found out. So this is equal to area from 0 less than z is less than 0.46, or I can break this in this manner. For better understanding, I will write it down as minus 0.46 less than z is less than 0 plus area from 0 less than z is less than 2.21. From minus 0.46 to 0 by symmetry, this is 0 less than z is less than 0.46 plus the area from 0 less than z is less than 2.21. So for 0 to 0.46, that is 0.17
1772.
plus 0.4865. So this is equal to 0.6637. Anyone have difficulty? Please ask right now. Fourth one, fourth one is 0.81 less than z is less than 1.94. So this will be equal to, let's draw the diagram first. Y-axis 0.81 will be somewhere here, 1.94 somewhere here. So area from 0.81 to 1.94 will be given by yes, anyone? How can we
Sir, we
do
have
that?
to subtract. Sir, we have to subtract area from 1.94, 1.94 from 0.81.
Yes.
So 1.9 for 1.94 it is 0.4732. Uh, yes,
0.438,
4732.
I guess, minus 0.2910. Just check it. Am I right or wrong? 1.9. Yes, 0.4738. So the
Yes.
final answer for this is 0.1828. Fine. The next one, left of minus 0.16. So that will be minus 0.6 somewhere here, minus 0.6. So left of this, it means this area I have to find out. So how can we do that?
Sir, half minus that
Yes.
0.6.
So let me just, left of minus 0.6 means that minus infinity is less than z is less than minus 0.6. So the total area on the left hand side is 0.5 minus the area from 0 minus 0.6 less than z is less than 0. But this area by symmetry will be equal to minus area from 0 less than z is less than 0.6. So this is 0.5 minus 0.2257,
2257. Yeah.
and the answer for this is 0.2743. Okay, the last one, right of minus 1.28. Chirag, you wait now. Let someone else answer this. Anyone else? How can we take right of that equal to minus 1.28? Okay, anyways, minus 1.28 somewhere here. The right of this, it means this area. So minus 1.28 less than z is less than infinity. Just tell me, Chirag. So that will be area from minus 1.28 less than z less than 0 plus the area from 0 less than z is less than infinity. So by symmetry, this is area from 0 less than z is less than 1.28 plus area from 0 to infinity is 0.5. So 0 to 1.28 is 0.3997 plus 1.5. So 0.8997.
So that must be 0.5.
Yes, 0.5. Okay. So that is all about the normal distribution. We will solve one example because all the types I have covered in this example. So just we need to see now how to apply this knowledge in our actual examples. Okay. Suppose heights of students follow normal distribution with with mean 190 centimeters and variance is 80 centimeters square. In a school of 1000 students, how many would you expect? How many would you expect to be above 200 centimeters? So first of all, I will have to find the probability that when I choose one student out of this 1000, he will have height more than 200 centimeters. What things are given to us? The first one, x follows normal distribution. X follows normal distribution with mean. Mean is nothing but mu. Mu is mean and which is 190. Variance is 80. So sigma square is mean is equal to 80. Oh, sorry, sigma square, which is variance, is 80. So this will imply that the standard deviation sigma is under root 80. So what we need to find, probability of x greater than 200 is to be found out, right? So probability of x greater than 200 will mean that probability of x minus mu divided by sigma greater than 200 minus mu divided by sigma. This is what I have changed the variable. So this will become z greater than 200 minus 190 divided by under root 80. So this will be probability of z greater than, what is the value, 200 minus 190 by root 80. One point 1180. Let's draw the curve. One point 11 will be somewhere here. So this area I have to find out. So probability of z greater than 1.1180 will be equal to 0.5 minus the area from 0 less than z less than 1.1180. So look at the value for 0 to 1.1180. The value 0.3665. So the answer is 0.1313. So out of 1000 students, out of 1000 students, this
So
is
it will be 0.1335.
0.1335. 0.1335 into 1000. So that is nearly 133 students, 134 students. Okay, so this is how we use this in the given examples. So our values in the examples will be in terms of x, then we convert it in terms of z, and then we find out the values. Next example. Let x follows normal distribution with mean 4 and variance 16. Then find first one, probability of x greater than 5. Second, probability of x less than 2. Third, probability of 6 less than x is less than 8. And the fourth one, probability of mod x greater than 6. So let's come to the first one. Probability of x greater than 5 is equal to probability of x minus mu by sigma greater than 5 minus mu divided by sigma. Put the values of mu and sigma. So probability of x minus mu by sigma will become z. So 5 minus 4 divided by variance is 16. So sigma, this will become 4. So probability of z greater than 1 by 4, which is 0.25. So 0.25, 0.0987. Is it right?
No, sir, we have to subtract it from half.
Yes. So 0.025, 0.25. This is the area we need to find. So that will be 0.5 minus the area from 0 less than z is less than 0.25. So this is 0.5 minus 0.0987. So the answer is 0.4013. Second one. probability of x less than 2. This will be equal to the probability of x minus mu by sigma less than 2 minus mu by sigma. So this is probability of z less than, so that will be 2 minus 4, minus 2 by 4, which is minus 0.5. So if we draw the diagram for this, minus 0.5, this area. So that will be 0.5 minus the area from 0 less than z is less than 0.5. So 0.5 minus 0.1915. 0.5 minus 0.1915, which is 0.3085. So the third one, probability of 6 less than x is less than 8 will be equal to the probability 6 minus mu by sigma less than z is less than 8 minus mu by sigma. So that will be the probability, or 0.5 less than z is less than 1. So if we draw the diagram, 0.5 is here, 1 is here, the middle. So that will be the probability from 0 less than z is less than 1 minus the probability from 0 less than z is less than 0.5. Tell me the answer for this. Whatever is the answer, you can write it down now. Who can tell me the last one? What do we mean by mod x greater than 6? This is usual. I mean, the third one you can complete it now. I will go for the fourth one. So probability of mod x greater
X
than 6.
between -6 to 6.
Are you sure? Mod x
Sir,
has to be greater than 6. Minus 6 is here, plus 6 is here. So you need mod x greater than 6. So which part it will be?
sir,
Can you
minus
add?
infinity to minus x
Yes.
union with 6 positive 6 to plus infinity.
Yes. So if you take a number beyond minus 6 and 6, so those numbers will have mod greater than 6 actually. And the numbers between minus 6 to 0 will have mod x less than 6. Am I right, Janvi?
Yes, sir.
So this will be probability of x less than minus 6 plus probability of x greater than 6. So this will be the probability of z less than minus 6 minus mu divided by sigma, which is 4, plus probability of z greater than 6 minus 4 divided by 4. So this is probability of z less than
Minus 2.5.
minus 2.5 plus the probability of z greater than 0.5. So probability of z, so this will be, let's draw the diagram for this. minus 2.5 is somewhere here. Less than this means this area. And for this, 0.5 will be somewhere here. Greater than this, it means this area. So this is equal to the area 0.5 minus the area from 0 less than z is less than 2.5 plus 0.5 minus the area from 0 less than z is less than 0.5. I hope you can do it now. If you have any difficulties in normal, please ask because this is the last example. Please put your name and roll number in chat box.